Hello, everyone. Can you guys hear me? You can?
Yeah, I can hear you.
That check means that you can hear me, that thumbs up. All right. Great. Thank you. Yeah, so I haven't done this in a while. Um, but anyway, the weather's not so bad yet. Okay. All right. So thanks for attending this. I will be, of course, recording it and I'll post a video later if you guys want to look at it. It should be recording. All right, so let's get started then. A few reminders. Again, the most important one is that exam one is Tuesday. Okay, so please study for that. Because of that, I'm not going to assign a homework um, today, and instead I want you to, dedicate your time to studying. Remember, the exam will have 10 questions or problems. It's going to be it's going to be closed notes, but you're allowed your cheat sheet, an 8.5 by 11 page, and you can write whatever you want on it. Okay, so that's kind of the idea. Are there any questions about the exam? So, like I said, the exam, 10 problems, could be scripting problems, could be Linux problems. I've not written the exam yet, so I'll be working on that this week, and I'll be posting it. I think I finished grading your first homework assignment. And I'll be grading the other two this week as well. Yeah, so that's it. So we are currently on week 5. So this is week 5. And this week we've been doing networking things. And we just focused on Scapy. So that's what I'm going to continue today. This homework assignment is it's a tougher one. There's only two problems. They're kind of the same. But I'm gonna want you now to do more of this on your own. So I'm just going to talk about the problem, give you as many hints as you want, but you have to implement it. Okay. And this is going to be based on a case also called the H.D. Moore case. So we're going to be doing that. Yeah, we're going to be doing that this week. All right. So are there any questions before I begin? All right. So I'm sharing the screen here. Close that. And I'm going to go to ITS 372. Okay. And I'm going to go to content. And as you guys know, we are covering Scapy. Oops. Okay. What's this? I don't know what I did there. Uh, Give me a second here. All right. Okay, I see what I did. Share the screen. All right, do that. All right. So let's go to the table of contents. Okay. Then maybe. So we are currently on module this one, network packets and Scapy. Okay. And the document, so I provided the Scapy link, which we went over on Monday. This is your lab homework, although this is going to be due 2 weeks from today, essentially. Um, we've got sniffing and spoofing, which is for you to read, not to complete. I will create an assignment link I will be creating an assignment link. This is one of the problems. So you can see here it says, as described in class, using a Python Scapy library, implement your own traceroute. For more information, see the attached PDF 2.3, task 1.3, traceroute. List all router IPs between your VM and your destination and indicate the number of hops. So I'm going to also, as I do, copy this into the Word document. I'll do Control copy, but it's going to be the same problem. Okay. So around. So I should have the Word document open. Yeah, I have it here. Word. Okay, so this is going to be your Word homework assignment, which, like I said, is in 2 weeks. We went over this in class essentially on Monday, right? So you need to install these libraries, you need to run all these commands as I did in the demo, and then just answer the questions as you see them. And it's essentially practice on how to, familiarize yourself with Scapy. You do the trace route and you print the graph. So that's what we did on Monday, just part of the lecture. Your homework, so will be completing that, just replicating what we did in class, and then solving these two problems. So the trace route is the first problem, which I'm just going to add the description here. Right, there you go. So your own trace route, and I should say with Scapy, just in case. With Scapy. Okay, so the problem is described in class using the Python Scapy library. Implement your own trace route. For more information, see the PDF. List all router IPs between your VM and your destination and indicate number of hops. You may need to set your computer to be in bridged mode so that it becomes like a local IP of your network. Do this at home, probably. Might be easier than doing it at the school. And the same goes for the Ph.D. Moore case. So I'm gonna, I guess I'll say below, just so that you guys can see it. Below should be a fun problem. Below, sorry, can't see me. All right, there we go. So below. And so this is really going to be, I kind of went over this on Monday. So I'm going to focus more on the Ph.D. Moore case today, kind of give you the case. Again, just like previous cases we've done in the past, it's a case where it's a system administrator, right? So it's a system administrator, and the system administrator had a problem, and they had to write a script essentially to try to solve it. So that was the idea. All right, and so this handout that I have here is going to replace the current one, and it's going to be your homework assignment due in 2 weeks after the exam. Are there any questions so far, guys? Oh, questions? Okay. Not hearing any questions. Oh, there's somebody in the chat. Okay, no questions. All right. Great, thank you. All right, so let's take a look at the Ph.D. Moore, and I have it also. I have it here. Oh, there it is. All right, so it's called the case is called How H.D. Moore Solved the Pentagon's Dilemma. All right, so here we go. So in late 1999, the U.S. Pentagon faced a serious crisis against its computer networks. Okay, the headquarters of the U.S. Department of Defense, the Pentagon, announced it was under a coordinated series of sophisticated attacks. And this is from the CIO Institute Bulletin on Computer Security in 1999. A newly released tool, Nmap, made it rather easy for anyone to scan networks for services and vulnerabilities. Okay, so they were doing, like finding open ports, kind of what we did at the beginning of the semester. To identify and map vulnerabilities in the Pentagon's massive computer network. An Nmap scan proves rather easy to detect. correlate the attacker's address, and then geolocate that IP address. However, the attackers used an advanced option in Nmap. Instead of just sending scans from their specific attacker addresses, so from their homes, let's say, they included decoy scans that appear to originate from many places around the world, right? So they were, the source IP was kind of random, if you will, from all over the world. So they included scans that appeared to originate from many places around the world. The Pentagon experts had difficulty distinguishing between actual scans and decoy scans. While experts pored over massive reams of data logs with theoretical methods for analysis, a 17-year-old from Austin, Texas, finally presented a working solution. H.D. Moore, legendary creator of the attack framework Metasploit, met with Stephen Northcott from the Navy Shadow Project, and they solved the problem, right? So I caught it off there. You can look it up online if you're interested. So that's the problem, right? So you guys understand somewhat. You have a network. It's being scanned, and you want to figure out who's doing this. So you want to trace back, which ties into traceroute, right? So if you look, the example that we did this week on Monday was traceroute, and traceroute gives you this idea of, okay, I just received an attack. What's the source IP? We know that we can sniff, because you learned how to do that this Monday also. I can sniff that packet, and now I can traceroute and find it and figure out who it is. Or something along the lines, or figure out which one is the authentic, and so that you can then find who's doing the attack. So that's kind of the problem. And so now we know, what do we know? What are the hints to solve this? Some of the hints are that we can use traceroute. We know that traceroute, the key is, as we saw on Monday, is the TTL flag. We can write, we can use Scapy and Python, right, to figure this out. So we need to write a script, essentially. All right. All right. So hopefully this is making sense. Please just interrupt me if if you have any questions on this one. All right, so let's think a little bit about it. Okay, so what do we know? All right, so we know that H.D. Moore, is randomly generating packets instead of using the value from the operating system. So we have to look at the TTL values somehow of the incoming packets, and find some kind of an anomaly, essentially. Right? So anyone that has an anomaly in their TTL, for instance, could be a candidate to be discarded. Yeah, so those would be decoy packets. If the TTL is a standard value, not an anomaly, then we can safely assume that the IP is legitimate and pursue via geolocation. We'll look at geolocation later in the semester, but just figure out, right? So, and track down the attackers. So how do we solve it? As I said, we are going to create a script that captures incoming packets. We can definitely do that with sniff and their corresponding TTL. Okay, easy enough. Then maybe we can do a sniff and spoof, where the script then sends ICMP packets to the IP address that sent the captured packet, in order to determine what TTL value that packet should have. So you can see how maybe we can get the TTL of the incoming packet, then send it back out, reply to that IP, measure the TTL, and possibly compare to see if there is a difference. All right, so as I was saying, so maybe that's the key, right? So we could solve this problem by creating a script that captures the incoming packet and their corresponding TTL value. We can then have a script that sends out an ICMP packet to the IP address that sent the captured packet in order to determine what TTL value the packet should have. Once this is determined, we can compare the two TTLs in order to determine if the packet has a normal TTL value or an irregular TTL. Do you guys see that? So that's kind of the approach. So we can think of it as that, I would say. And now maybe the key, obviously, you guys will argue that, it might take a different route and it's going to be several different routers across the way. So the difference, it won't be an exact match. So we have to take that into account. So if the difference between the two TTL values is larger than, say, a specific value, then the IP address is most likely a decoy. So we have to be a little bit flexible in providing some kind of a threshold to say, okay, well, if it's more than 4 hops or something like that, or 8, so you'll have to play with this. Remember, guys, that you have to ensure that this works. I'm going to provide some ideas, but I do want you guys to work on this and solve it by yourself. All right, so let's add those hints, right? So the hints are sniff attack packets. So sniff attack packets. And then what? And collect TTL data and source IP. Then send ICMP packet to source IP. Okay. Like a trace route, like trace route from problem 1. Problem 1. Okay. Then obtain new TTL and compare to original TTL. If the difference between TTLs is greater than, let's say, 8, that IP, that source IP, P is likely a decoy. Does that make sense, guys? Does that make sense? Any questions? Questions? All right. Sounds like you guys understand. Not seeing anything in the chat. All right, so this is going to be your homework assignment then. We'll start writing a little bit of the code here just to kind of give you a starting point, but then I'll let you guys just work on it or ask any questions about the exam. Okay. So All right, so this is the document, right? So this is homework, Scapy. I've provided the two problems. You have the case and some hints. I'm going to save this document. Scapy Basics. I'm going to go to your course website. So the Scapy, I'm going to remove the old one because I've updated it. Okay, so that one's gone. And I'm just going to add the new Word doc. Going to be Scapy Basics. Okay, click add. All right, so the new document should be there. So I'm going to go to table of contents. And yeah, so we're just, let me move this thing so always in the bottom. All right, so exam one, that's Tuesday. Today you'll be working on this. So I'm going to create the assignment link, new assignment. And like I said, because of the exam, because I want you to focus on studying for the exam, I'm going to give you 2 weeks for this one. Just going to say, somebody asked a question. Right, so someone asked, Tuesday is in-class exam. That is correct. So unless there was a mandatory university thing where they say there's a storm, if something like that happens, guys, what you can assume is I'll postpone the exam to the following time, okay? Yeah, sorry, Monday and Wednesday, I apologize. I used to always teach Tuesday and Thursday, so it's kind of set in my brain. But yeah, Monday is the exam. Sorry about that. Monday. Monday. Okay, I apologize. If we have another snow day or something like that, I'll postpone it until we meet again in class. But for now, it is scheduled for Monday in the classroom. And it's going to be, as I said, a written exam. You download the Word document, answer the 10 questions, could be problems, etc., and then upload it back to Brightspace. Make sense? Okay, great. So yeah, so the exam is Monday, and because of the exam being on Monday, I will not assign a homework this week, and instead this one will be due 2 weeks from today. So I'm gonna do homework. I'm gonna call it Scapy and H.D. Moore. Okay, the case. So due date. So today is the 12th. Exam was on the 17th. 19 will just have a regular class. So it would be due on the 26th by 10 p.m. And I'll say complete the attached Word document with Scapy problems and H.D. Moore case. All right, so that's the description. And then it's available from now, and it'll stay open until the 1st of March, I guess. All right, so that, I'm gonna click save. Should have saved. Okay, so we'll go back to the table of contents. All right, so there's the homework, and it's based on this Word doc, and you can use the rest as references, etc. All right. So now that we understand that, the last thing I'm going to do today before I give you time to work on these things is I'm going to help you out a little bit with H.D. Moore. just some of the logic without giving you everything. And I'll just provide some comments essentially. All right, so somebody asked me the question, can you explain about how the exam is going to be, please, in person? And would it have questions like fill in the blanks or anything like that? So the exam is mostly, I would describe as essay type. Okay, so no multiple choice, no fill in the blank. It's not, I don't usually go for memorization. I'm going to ask you to explain things, but you have to know how to use the commands. You have to know the syntax of cron. You have to know the syntax of access control, right? And everything else that we have covered in the course. Got it? So it's a combination. A problem could be explain, what is the Unix way? It could be something like that. Or I could ask you, um, you know, uh, change the permissions to this file to be read only for group, you know, or it could be a script. You don't need to have screenshots in there, obviously. It's a written exam, so I'm not going to ask you to run it on the computer or anything like that. But you need to give me, if I ask you for a cron entry, you provide the cron entry. Got it? And everyone else good? All right. So now, sure, you can take, yeah, you can take the exam. Right. All right. So let's go ahead now and start the virtual machine. Okay. Start the virtual machine. And we're just going to, as I said, play with the VM VirtualBox. And we're going to go over this script. And it's the beauty about these scripts, hopefully you've noticed, is like, they're not like your website assignments with JavaScript or whatever it was, which were massive. Scripting is meant to be pretty short. A few lines of code here and there is all that you need. And to solve this problem, if you think about it, this was a valid problem, right? That could easily be solved with, a little bit of scripting. All right, so the virtual machine, you should be seeing the virtual machine starting up. And we're going to go over the basic ideas of the script. All right, so here we are. All right, so I'm going to click on seed. These. All right. Let's open up the terminal. So you should all be seeing the terminal. I'm going to navigate into the desktop. Here. OS-L. And then ITS 372 Spring 2025. Hit clear. All right, so we were doing network Scapy, so I'm just going to continue using that. Hit clear. All right, here we are. So I'm just going to call this one HD more just to kind of make it, obvious. HD more. I've already read through the case. We've talked about the hints, etc. Okay, so we need to figure some things out. So obviously, Scapy will be one of the things um, for us to consider here. So let's think about the logic. So I'm going to write kind of like pseudocode, but we need the library. So from scapy.ol import all, right? So this is what we were doing um, on Monday, and we're just going to continue to do that. Okay. All right, so I have the library. Now, what do we need? So we need a sniff and spoof, right? So that means we need sniff here and let's just say PRN, which we knew about. And we're going to create a function. Let's call it test TTL. Okay. All right. Because we might be collecting a lot of data, let's set it to 0. Okay. So that sniff is essentially sniffing on the network, capturing data. Any data that we capture, we're going to send it to the function test TTL, which we have to define. So define test TTL. Remember that as I said in the beginning of the class, the TTL variable is the key. We have to somehow have an original and a new TTL and compare them. Okay. So let's think about that. So 1, 2, 3, 4. And let's just say return for now. So test TTL takes, of course, the packet that we provide, as we showed in the example on Monday. 1, 2, 3, 4. Okay. So what does test TTL? We also talked about the try catch initially. So let's use that just in case something would cause the program to break. So I'm going to do try 1, 2, 3, 4, return. Oh, sorry, not return, accept. Okay. Given that we have that now, I can get rid of return. So essentially our code will be here, and if we have an exception, we'll just ignore it. So usually you can do that with 1, 2, 3, 4, just a command pass. So that will allow you to ignore any error and just keep going. You have to think of this script as something that would be sniffing the network, collecting packets that are attacking you. It's an active attack of many packets coming in, and you would just send things out, send things back out. And then when it finds candidates that are not decoys, it's going to create a log, etc. So this assumes, of course, that some of the packets are coming from legitimate places. So this was the assumption in this case, which may not always be the assumption, but for this example, it works. Right? And we can practice Scapy in Python. So then 1, 2, 3, 4. All right. So now we have to think of what we want. So the first thing is probably to get the TTL from this packet, right? So how do we do that? So not all packets that arrive, I didn't put in a filter in here, if you notice. So, because not all packets might be ICMP packets, etc. Instead, we're going to have to do that filtering here. So 1, 2, 3, 4. Let's say if something. So we have to think about this. Yeah, let's make sure it's an IP packet, I suppose. So I'll give you this part. If packet dot has layer and the layer that you're checking is IP. So it's an IP packet, essentially. First thing that we're checking. Okay. 1, 2, 3, 4. If it has that, then we are going to get the IP source, which we also need. So IP source equal pkt dot get layer IP, and from there we're going to get the source, right? So we get from the packet the IP layer, and then from the IP layer we get the source field. Okay, so we got that. We can also get the TTL from the packet, right? So that's the next thing, the original TTL. So TTL, right? So from PKT, dot TTL. So that should give us that part. So that gives us the fields that we need, essentially. All right, so we know that. Okay. Once we have the TTL and the IP for a packet, what else do we do? Well, at this point, we need to process that IP and that packet and, get the new TTL, essentially. So let's just call a new function check TTL. And this is the function that will be a bit challenging. We're going to provide to this one IP source, which is the IP address. And we're also going to provide the TTL, if that makes sense. So that should give us, so now we can go over here, define check TTL. That takes in IP source, comma, TTL. 1, 2, 3, 4. Okay, so we have that. So this is the part that I'm kind of leaving to you for the most part. So from now on, I'll just write like in pseudocode the ideas. So what do you need to do? So the first one is, of course, 1, 2, 3, 4. Given that information, so I'll just put a comment here. Craft a new spoofed packet. All right, so you're going to craft this new spoofed packet. I would say that IP source needs to become IP destination. So IP destination is now IP source because you are sending back out, right? So you need to do that. You need to do that. What else? So yeah. And so so that's kind of straightforward. You need to create the spoof packet. What was the hint for creating spoof packets? If you remember, I gave this to you on Monday. Let's say PKT spoof is equal to what? And if you remember, I did something like this. IP, right? And then I did that. and then I did ICMP, oops, ICMP, and then I did, uh, X maybe, right? So obviously this part you have to figure out, but you have to craft, the key is craft a ping packet. Once you craft the ping packet, um, what do? You send it, right? So you need to send the packet. So send the packet. Here, in class on Monday, I showed you the send function, of course. And you can try with that. So try with this. There's another function that is in your Word doc to practice, and it's called SR1. SR1. So the SR1 function is another option. And I'll let you guys play with that. So send or SR1 to send packet. Okay? The spoof packet, essentially. Any questions so far, guys? All right, nobody's saying anything. All right, no questions. So it seems like it's clear. Good. All right. So yeah, so that's the idea. Probably in check TTL, I would recommend also using the try catch. So I would just, oops, try, except just in case it breaks in one item, but others can go through. Remember, 1, 2, 3, 4. Just let it pass, and your code goes here. 1, 2, 3, 4. Your code goes there. All right, so SR1, what is SR1? So we know that we've created the spoof packet, and SR1 is really nice because it's a function that the way that I would describe it is you create an object, like a process in memory, and that process sends out the packet, but it remains in memory. It kind of like creates a port. So so the packet sends out, but it opens a receiving port so that when you send out the ping, the echo request, when you get the echo reply, it'll come back to SR1, to the port that it opened. So essentially, SR1 gives you this functionality of sending a packet, waiting, and receiving the response. So I'll write that down here. So I'll say SR1 sends a packet and waits to receive the response packet. Okay, so that's really nice. It's very useful. So think about how that would work because you're trying to send an ICMP packet. It's essentially a ping, but you care about the response, right? So you care about the TTL of that, how many hops did it have, if that makes sense. So that's one suggestion that I would give you guys is to do that. So then the syntax for SR1, which is already in the handout, by the way, would be something like response equal SR1. And then in SR1, you have several flags that you can define. The first thing is obviously the spoof packet goes here. Spoof packet goes there. And then there are other parameters like retry, also timeout, and I'm sure more. So play with those. If you get a response then the response object would have the data that you need. So response would be either something like .ip.ttl or something like that, and that should give you the answer that you, oops, that should give you the answer that you're looking for. Obviously, after that, compare old to new TTL and check that difference is less than or equal to some kind of a threshold. All right. Do you guys understand? That's essentially the logic for check TTL. As I said, I do want you guys to try to solve this. I'm giving you 2 weeks. Yeah. Any questions? That's the homework for the next 2 weeks with Scapy. And I've given you most of it, right? So if you notice, solving this should take 4 lines of code at most. And I've given you a lot of the details. You just have to put it together. Any questions? Let me save this before I lose it. So I have it available. If you guys have questions. Yeah, well, it should be good. Any questions, guys? Make sense? Not hearing any questions. Everyone seems to be clear. All right, so that's kind of the demo for today. All right, so I'm going to, at this point, I'm just going to stay for the rest of the session in class. If you guys have any questions, ask them, work on this if you'd like, or work on the assignment. And then, but this, I will stop the recording now.